Hey everyone, ever look at a piece of code and it just looks like a foreign language? Well, today we're going to change that. We're taking this Python function and we're going to tear it down line by line. By the end of this, you'll see exactly how it ticks, and you'll be able to read it like you wrote it yourself. All right, so here's the game plan. First, we'll figure out what problem we're even trying to solve. Then we'll make our tool for the job the code itself. We'll take it apart piece by piece like an engine. After that, we'll watch it run live, and finally, we'll talk about the bigger picture, the kind of thinking that lets you understand any code. Okay, first things first. Before we even glance at a single line of code, we need to wrap our heads around the problem it's designed to fix. It all boils down to a simple math concept. So, have you ever seen this in a math problem? A number with an exclamation mark right after it? No, the number 5 isn't just really excited about something. In the world of math, this little symbol has a very specific job. It's called a factorial, and all it means is you take that number and multiply it by every single whole number all the way down to 1. So for 3, it's just 3 times 2 times 1, which is 6. Easy enough, right? But what about, say, 50 factorial? Yeah, you're not going to do that by hand. That's why we need a machine to do the heavy lifting for us. And that's exactly where our code comes in. So let's meet our tool. This is the elegant solution that programmers came up with to solve this exact problem, a simple function written in Python. And here it is. Now, I know at first glance it might just look like a block of text, but I want you to stop thinking of it like that. Think of this as a tiny, specialized machine, or maybe a recipe. It's built to do one thing and one thing only: calculate factorials. So let's see how it's built. All right, time to get our hands dirty. We're going to pop the hood on this machine and look at its anatomy, piece by piece. We're breaking it down line by line, starting right at the top. Okay, check out this first line: def get factorial of n. This is where we're basically teaching the computer a brand new skill. We're calling it get factorial. Then look at the next two lines. This is super important. It's like putting a bouncer at the door of a club. It checks for any bad input, in this case negative numbers, because you can't get the factorial of a negative, and if it finds one, it just stops right there. It's such a smart and safe way to write code. Now we're in the engine room. Line 4 creates what I like to call our shopping cart. It's a variable named result where we're going to store our answer, and we started off with the number 1. Then you get to line 5. This is the engine itself. It's a for loop, and its job is to chug along, counting from 1 all the way up to whatever number we gave it. And line 6, that's the real workhorse. It's the accumulator. With every single pass of the loop, it takes what's in our cart and multiplies it by the current number. It just keeps building and building. And here's how we wrap it all up. Line 7 is where the function says, "I'm done," and hands back the final product, that finished result. Then, the next couple of lines are where the main script takes over. It asks you, the user, for a number and then feeds it right into our get factorial machine. And finally, line 10 catches the answer that comes out and presents it in a nice, clean sentence for us to read. Simple as that. Okay, so we've seen all the individual parts, right? The bouncer, the shopping cart, the engine. Now let's put it all back together and actually watch it run. We're going to trace the code with a real number so you can see exactly how the computer thinks its way through the problem. All right, we're going to feed our machine the number 3. Now, pay close attention to this table. You're going to see how the values for I and result change with every single step the computer takes. Okay, so the function gets called with the number 3. The very first thing it does, before the loop even starts, is it sets up our result variable. You can see it right there in the table. Result is now 1. Our shopping cart is ready to go. And the loop kicks off. First time through. The value of I is 1. So we take our result, which is 1, and multiply it by I, which is also 1. So as you see, the result is updated, but it's still 1. No change yet. Here we go. Second pass. The loop runs again, and this time I becomes 2. Now things get interesting. We take our last result, which was 1, and we multiply it by our new I, which is 2. And boom, look at the result column. It's now updated to 2. And for the grand finale, the last iteration, the value of I is now 3. We take our current result, which is 2, and multiply it by 3. The result gets updated one last time, and we have our final answer. And that's it. The loop is done. The function hands back that final value sitting in the result variable, 6, which of course is the correct factorial for 3.
That's that aha moment, right? You see how those simple, tiny, repeated steps all add up to the correct answer. It all just clicks.
So what's the big deal here? I mean, beyond just calculating a number, what did we really learn? This whole process teaches us something way more important. It's a way of thinking, a framework for solving problems. It's what we call the programmer's mindset. This is the real toolkit. First, you learn not to get overwhelmed. You break big, scary problems into little, bite-sized pieces. Second, you start to see that every single line of code is there for a reason. It has a purpose. There's no fluff. Third, you learn to think like a computer, step by step, tracing the flow of data just like we did. And when you put all that together, you start recognizing the patterns, things like loops, accumulators, guard clauses that show up everywhere. These are the fundamental building blocks for solving just about any problem you can imagine.